zahlreich da sind. Also ist schon überraschend für so eine Veranstaltung. Carsten.
Yeah, thank you. Also welcome from my side. Yeah, we are not here to show our new dancing group, but to speak about more interesting topics. Yeah, welcome from my side to the final talk of this term, and as usual I like to make a quick announcement. And for those of you who don't know me yet, my name is Carsten Tellmann and I work for GData. That's an antivirus company located here in Bochum, and we are supporting this course. Basically, we think it's really important to know about offensive mechanisms to implement really good defensive mechanisms. So it's really a good thing to be here, not only if you want to hack something, but also if you want to work for the good guys later on. Yeah, basically we offer an additional evening event. You see the facts here. We will have some food and drinks, and we have a nice atmosphere in my company where we can hopefully have nice discussions. So if you're interested in talking to our speaker a little bit more detail on specific topics of the talk or in general, or if you want to get in touch with some people, technical people working in an antivirus company, all of you are welcome to join us. If you have questions, don't hesitate to come to me after the talk, and when we can talk a little bit more in detail about it. And yeah, that's it from my side. Now, let's enjoy the talk.
Hello everybody, I'm honored to be here. Just a while I changed the setup. Who I am. I work at a small software house in Palermo. I also run a security consulting firm called Academics. And I'm here mainly because I created the NoScript browser add-on about 8 years ago. And because of that, I am a member of the security group at Mozilla, and I'm also a contributor to the Mozilla code base. I've worked on the security module and on the front-end module. And I'm also an invited expert at the web application security working group at the W3C. The W3C is the consortium of browser vendors, web server technology vendors, but also web services providers such as Mozilla, Google, Microsoft, PayPal, which aims to standardize all the technologies which are related to the web. I am one of the 10 most dangerous people on the internet, according to Robert Hansen, which you may know under the nick of R-Snake. He told it in OWASP presentation in 5 years ago, but I believe he still fears me. Because I'm the one who can subvert the code of NoScript. NoScript is used by most security experts, so I can subvert all the customer of most security experts by proxy. So I'm dangerous, yeah. All right. And I'm mostly dead. Most of the time I make the dead at home, so you may say these are the worst enemies of NoScript because taking care of NoScript is time-consuming, energy-consuming, and rewarding almost as parenting 3 children. You may say, why? Because NoScript is essentially an extension of a browser, so you may think it is a teeny thing, something which is easy to develop and maintain. But in reality, it's quite a complex thing, because obviously it is a script blocker. It blocks script and other active content such as browser plugins, media files, frames, and less known things we'll see later. But also it implements the first and still most effective cross-site scripting filter in a browser. It provides lots of improvements over the management of secure connections. Most of all, it gives more control to the user on how HTTPS is used by the browser. Oh, sorry. It contains a module which is essentially a full-fledged web firewall called ABE, Application Boundary Enforcer, which provides protections against cross-site request forgery. And it contains a module called ClearClick, which is currently the only effective client-side protection against clickjacking. And many other minor things which make the code complex and the maintenance activity quite burdening. If we look at the changelog, which is a changelog which spans for 8 years, we see more than 300 kilobytes of text, more than 700 stable public releases, and much more intermediate betas and so on. About 800 new features added over the time. Twice the sum of bug fixes and enhancements, and even 35 feature removals, because over the time many of the technologies or fixes or workarounds implemented in NoScript to improve the security of the browser have been built in the browser, so they were obsolete. Why all this activity around NoScript development? It's what I call emergency-driven development. Now, I'm here to talk to people who make offensive technology, offensive security, and have an offensive mentality, I suppose. But I aim to recruit you to improve NoScript, because NoScript over the time has improved mainly because of people with an offensive mentality, an offensive security posture, which have broken NoScript to make NoScript better. So I'm here to call you to break NoScript. Of course, the fact that Firefox has switched to a fast development cycle of 6 months and breaks routinely extensions because changes code which NoScript use as its part in this fast development. And NoScript is not for everyone. NoScript is for power users, and power users always want it their way. And usually their way today is not their way tomorrow. For every new feature, they want to be sure they can turn it off, they can customize it. So this leads to a situation which is embarrassing, because it has a price, and this is the price. We got in NoScript today 5 panels only for basic options, and the advanced option panel has 6 sub-panels for a total of 80 user-facing preferences, which is really a lot. I know it's a shame, but I am trying to improve the thing, but we'll see it later, because the real burden is more than 300 hidden preferences, which can be accessed through about config. So you may say it's too much configurable, this tool. On the other hand, making default values for all these preferences is really hard, because you must give a product which is the best mix between usability and security to people who install it first time. So what am I doing about it? At this time, we got two NoScript. NoScript for desktop is mostly different in code than NoScript for Android, because I took the chance of porting on Android to rewrite most of the code in a more modern fashion and to streamline features which were too bloated. Also, I had to simplify the user interface because the main target was mobile devices. And I implemented presets for the most common configurations of NoScript. Let's say a beginner preset with more emphasis on usability than security, and hardened preset with more security and less usability, and a couple steps in the middle. Obviously, I took the chance. I said to modernize the code base, making it more maintainable, remove the old stuff. But this version is still not ready for the desktop. Eventually, it will be merged in the desktop version, but there are minor features which are not ported yet. What is currently ported is the script blocking, the content blocking, the XSS filter, the AB module, and the clear-click, anti-click jacking technology. So most of NoScript is on Android, but there are lots of minor features which, if removed abruptly by an automatic update of the desktop version, will make an outrage among users. So I need still to work to the merge to make it seamless. You can watch or download or reinstall NSA, NoScript for Android, using that URL. You can install also on the desktop, but as I said, it's not the same as desktop NoScript. Okay, let's run through the features, the main features of NoScript and their history. Script blocking is not so basic after all, because we block inline scripts and workers. You know what workers are multi-threading for JavaScript, are external files which can be executed in a separate logical thread. Browser implementers may choose to use hardware threads, operating system threads, or pool of threads, but they are executed in parallel with the inline scripts, and we block both. We block separately script inclusions. So if you allow a website, many people use it to criticize NoScript because they say, okay, you've got a whitelist, you whitelist a popular website you use a lot, then this website gets compromised and you are pwned. You are owned, I just say. In reality, it's a bit more difficult than because usually when a website gets compromised, the exploits, the attacks come from a third-party script, usually hosted elsewhere in Russian, Chinese, if we want to be racist, or in a USA domain, which is not usually very popular or likely to be whitelisted. Then we got a certain granularity in how we whitelist the websites. We could, but we usually don't, whitelist an entire protocol, let's say HTTPS, and say, okay, all the website we come from HTTPS are whitelisted. I usually don't do it. And we can whitelist only the authority of a website, which means protocol, host, and port. Then we got a blacklisting mode, which allows us normally to hide website we are sure we will never whitelist, but also for users who are annoyed by the default deny policy of NoScript, it can be used to really blacklist only the websites you don't want script to run, and whitelist everything else with one single command. And then we got an option to auto whitelist only the top website when we visit it, which for some strange reasons appeals some users who value usability over security, but personally I would never use it. Oh, these are basics of script blocking, and even so they are hard to get them right, especially if you don't have a solid foundation in the browser you are using. NoScript is still only a Firefox extension, because the technologies it uses to make script blocking pre-exist NoScript. They were not used, or they were used by a few hackers, but they existed. And they were tested in the Mozilla code base. In fact, I had to hack that part of the code of the Mozilla code base, because since they were not exercised a lot, when I implemented the first version of NoScript, I had a lot of crashes, because NoScript used that code in a heavy-duty way. And so we found a lot of bugs which were not logic bugs, but usual careless coding about the module. And we took 6 months to clean up that code, which is called CAPS, capabilities, to do script blocking right. And so far, nobody managed to work around NoScript in its basic task, which is script blocking. While we got 3 clones of NoScript on Chrome, and all the 3 don't manage to block scripts. They are called script save, not scripts, and another which I don't remember right now. They present themselves as NoScript for Chrome, but they actually don't manage to block scripts in every situation. So if a script blocker can be worked around even in one situation, it's not a security tool, it's a joke, right? So one of my to-do items for 3 or 4 years now is finding the time, the connections, and the financial power to make a serious porting on Chrome. But so far, even to Google got in touch at least 3 times to say we are here to help. In reality, there's not much interest from Google to have a working NoScript on Chrome. So I'm planning to look closely at the new fork of WebKit, Blink, the new engine under the new versions of Chrome, to see if it can be hacked to allow a NoScript porting. But as I said, it's in my to-do list for 3 or 4 years, so don't hold your breath, as they say. Okay, let's go beyond the basics. Staying inside the script locking thing, there's a protection mechanism which is mostly undocumented in NoScript, but should be mainstream in browsers. NoScript automatically blocks, even if whitelisted, every script or cascading style sheet inclusion which have not a matching content type, which have not the right content type, a header for that kind of file. For instance, if the browser tries to execute JavaScript from a file which is called test.js, but as a content type header of application or of zip, NoScript refuses to load this file. Now, why is it very important for NoScript user but should be implemented by every browser? Because we've got lots of very popular websites which are meant to contain user developed code or user controlled files, but should not allow those files to execute. I'm talking mainly about code repositories like GitHub or Google Code. There are lots of websites which don't want to pay for a commercial CDN and use this kind of repository to download, to include scripts from either from popular libraries or from their own projects. So they abuse of the bandwidth of this website, but most importantly, they jeopardize the security of NoScript users who use those websites, because they're likely to whitelist those websites. A GitHub user probably has whitelisted GitHub. And then he goes on another website, he whitelists it, and GitHub may be used to host a malicious JavaScript which snoops on that page, which actually does cross-site scripting on that page. And it's already whitelisted, but GitHub didn't intend to give its user the power of using it as a CDN. GitHub sends a header which says, this is not a JavaScript file, this should be only downloaded. In fact, if NoScript sees either that the file is served with content type different, or is served as an attachment. So content disposition attachment, if NoScript sees that, blocks the file. So this attack scenario, which applies to any script blocker which makes whitelisting, doesn't apply to NoScript because of this reason. Now, beside breaking freeloaders, there's no reason, and in fact Internet Explorer partially does it, not to implement this safeguard to script inclusions to any browser. It's simple, really. Everybody should do it. Now, script blocking breaks a lot of sites. This is undeniable. What does NoScript do to mitigate this? NoScript has a handful of features which are meant to improve usability of sites where JavaScript is disabled. NoScript tries to fix navigation items which depend on JavaScript, such as JavaScript links or drop-down menus select elements which have an on-change event handler to change the current page, for instance, or submit buttons which work only with JavaScript, or JavaScript-based redirections. NoScript attempts to give user automatically a way to navigate from the website without allowing JavaScript. On the same line, but maybe now less useful since we've got a frame option, which is a mechanism with supersedes frame busting. Script blockers, when first click jacking has been revealed, script blockers have been criticized because they broke frame busting. Frame busting is the technique usually based on JavaScript to make a website not frameable, not allowed to be included in another website as a frame. It usually is a piece of code which checks if the current page is the topmost, and if it is not, it reloaded it as the topmost. Over the time, we've seen frame busting doesn't actually works because it has a lot of issues, mainly timing issues. But at the time, it was an issue, and NoScript implemented frame busting emulation, which incidentally worked. Then another usability feature is forcing the visibility of the NoScript tag. The NoScript tag, everybody knows, is the HTML element which is used to provide a placeholder for content which depends from JavaScript, but it's shown usually only if the main page has JavaScript blocked. So if we got the main page with JavaScript enabled, but we got inclusions which don't load because NoScript blocks them because they're third party, NoScript shows the nearest NoScript element to provide a placeholder and usability hint. But the most important feature along this line are script surrogates. Script surrogates are scripts which are executed in place of the scripts which are blocked by NoScript. NoScript has a lot of built-in surrogates for the most popular scripts, such as Google Analytics or Twitter or Facebook, which are normally included in other pages, which may or may not make their own script depend on the presence of this script, which most NoScript users don't like. No NoScript user likes to have to allow Google Analytics in order to run another page. But sadly, many websites depend on the presence of Google Analytics. If they see Google Analytics has not been loaded, either don't work or even enter in an infinite loop and cause damage to the navigation. So NoScript implements this feature, which makes the website believe the script is there. Of course, it may be used in more creative ways because it is a very flexible feature, which reminds of GreaseMonkey. GreaseMonkey is a browser extension which allows you to run arbitrary scripts you create on certain web pages. So user-provided scripts which runs on web pages, but with some twists, because script surrogates knows if the scripts are blocked or not. So you can have script surrogates which runs which run on blocked pages, script surrogate which run on allowed page, script surrogate which run on both. Script surrogates which run instead of an inclusion, like the Google Analytics one. So the browser tries to load Google Analytics, NoScript blocks it, and execute a surrogate instead of Google Analytics. A feature which has been requested by Richard Stallman. Everybody knows Richard Stallman of GNU. Okay, is replacing remote scripts with local alternatives, because the guy is religious about software freedom, and he believes that if we load inside our browser a minified script, or otherwise a script which has not a license, an open source license, a free software license, we are jeopardizing our freedom. The guy is made so, but I obliged. He was happy, I was happy. So we got this feature. If you want to play with surrogates, we got no connection. Okay. You may follow this URL if you get a connection. There's a quick reference with all the kinds of surrogates. You can make any surrogate you want to make for your own needs. So much for usability features. So what of this script locking in NoScript has creeped into mainstream browser? First, an ancestor. Before NoScript, there were in Internet Explorer for a long time the so-called security zones. Security zones are something like the whitelist or the blacklist of NoScript. You can define a list of websites with different permissions. Permission to run ActiveX, permission to allow cookies, permission to run JavaScript. So with some hard work, you could configure Internet Explorer. Since Internet Explorer 6, if I recall right, you can configure Internet Explorer to work like NoScript. The problem is that when you go on a website which tries to run JavaScript, you get an alert. Say, oh, this website wants to run JavaScript. Do I allow or not? A modal alert. So it's practically unusable. If you hate yourself, try, but I don't advise. Opera. After NoScript became quite popular, many Opera users, a significant percent of Opera users asked for something like that on Opera. And the Opera philosophy was, because if I recall right, now they've got extensions, but at the time was everything built in the browser. So they made NoScript into the browser, at least for what concerns script blocking and content blocking. It's called site permissions. Is rather nice, because but we'll see the raw script blocking NoScript approach has many weaknesses, which of course apply to this approach. So it's not that good for security. Chrome's 2 has built-in JavaScript options. You can configure it to default deny JavaScript and allow side by side, and it's very similar to Opera's site permissions. Firefox has done the opposite. Firefox has just removed also the one checkbox which allowed you to turn JavaScript on or off. They decided you either run a browser with JavaScript or don't. In reality, they know that whoever wants to block JavaScript in Firefox is better off installing NoScript and blocking it everywhere except where it is useful. So Firefox removed the ability to block JavaScript because fundamentally it is saying install NoScript. Oh, another legacy is CSP. Do you know CSP, Content Security Policy? Probably yes, is a technology delivered through HTTP headers, which allows web authors to define policies for the page which is loading, such as don't load third-party scripts, don't execute eval, don't execute inline scripts, don't run plugins, and so on. In practice, you can define a policy much like the script and active content policy of NoScript using these headers and have it apply to your web page. And the same, it's the sandbox attribute of iframe. Both technologies are web standards, are being standardized by the W3 consortium. Active content blocking is also about controlling embeddings such as Flash, Java, Silverlight, other plugins. Also video and audio elements. Why? Because the codecs used by these elements are very young. So it's very easy that we find ways to execute arbitrary code through a broken stream served to these elements. So likewise, it blocks plugins. NoScript blocks also, is capable of blocking this media if you want. And so frames. Less known stuff that is blocked just like plugins with a placeholder you can click to run the code are WebGL canvases, which are canvases which run 3D shades much like OpenGL. And they've already been found many times faulty in their implementation at the point that they can be used to exploit vulnerabilities in the graphic cards. So you may want to have a click-to-play policy for WebGL, and NoScript does. XML transformations because they contain a scripting language. Web fonts for the same reasons as media, because it's relatively easy to exploit the parsers for these fonts, because they have not designed for the web. They've been designed for a non-hostile environment like your operative system. When they are fed with content coming from remote, they are likely to be exploited. It's happened. The audio API, because the audio element is not the only way you can play sound files in a web page, but you also have a JavaScript binding for this. And Live Connect, you notice the cross, which means that Live Connect is not much alive anymore, because Mozilla finally killed it 6 months ago. But it was a pretty scary thing, because you believed you had blocked Java, you had blocked applets, but in reality you could run arbitrary Java from JavaScript, because you just imported Java classes inside JavaScript, inside your script, with fundamentally an import statement, and this act loaded a JVM and let you use all the JVM from JavaScript. So if there was a JVM vulnerability, you could exploit it without any applet, just with a script. Okay, so blocking Live Connect was quite tricky for NoScript, because it had to use a a script surrogate to do it. A script surrogate which ran on allowed pages to replace the object which were used to import JavaScript to import Java code in JavaScript with empty stubs. So the web pages which tried to use Live Connect in reality did nothing. Okay, so it was not a switch or block Live Connect or allow Live Connect. There was a lot of work, and I'm really grateful to Mozilla to have killed this cool feature. Yeah, cool, but dangerous feature, because I removed something like 400 lines of code just that day. Thank you, Mozilla. Okay, what of embedded control is now in browsers? Click to play, which was seen as a folly, a craziness when I implemented it in NoScript, now is common in browsers. We see it in Chrome, we see it in Firefox, even it will be in next public version. It is already in beta. To some extent, for ActiveX, we see it in Internet Explorer. Site permissions have embedded controls, so we already said CSP and Sandbox. Oh, I know you are brokers. You are people who break things. Okay. This is the coolest thing of NoScript you can break. I require you to break it, because this is the single thing of NoScript which has grown a lot thanks to people like you, thanks to Mario Edrich, thanks to, yeah, we got okay, and other people just like you who dedicated a lot of energy in breaking it. The AntiXSS Filter in NoScript, which was implemented in 2007, and when I implemented it, nobody believed it was possible. Actually, I didn't not know much about cross-site scripting at the time. I only knew that people kept repeating me that NoScript was a joke, because if I whitelist one site which allows cross-site scripting, which is vulnerable to cross-site scripting, then any website can run JavaScript code, and it's true. If I whitelist google.com and then visit a porn website which is not allowed to run JavaScript, but google.com has a cross-site scripting vulnerability, that porn site which has an attacking code can use it to run JavaScript in the context of google.com, which is whitelisted. So I had to make a hard crash course about cross-site scripting, and try to create a filter, because otherwise I understood NoScript was a joke, was not a security tool. So I implemented this filter. Nobody believed that it worked. But there was this nice community at slackers.org. Some of the people who teach us here probably was a slacker at the time, who had been so kind to try to break this filter. And they mostly succeeded, but every time they broke the filter grew stronger, at the point that became so stronger that now is the strongest of all. You had Jeremiah Grossman last week. You probably know RSnake, Surdercat, .Mario works here, all those people and many other contributed to the AntiXSS filter by breaking it. And I ask you to keep this tradition of this beautiful university. Thank you. Okay, so how does it work? This particular XSS filter works only on the request. It examines it deeply. It examines it recursively. If it finds inside the request an URL, examines it. It examines the post payload. It examines the referrer. It examines the headers which are likely to be outputted by the web applications. So you may say it examines all the requests, but not the response. And this is a great difference with the other XSS filters which have been developed after, because NoScript has a bit more false positive because of this, but also works on reflective XSS and DOM-based XSS, something a filter which validate with the response can do, because in a DOM-based XSS we don't get to see the same stuff which was in the request. We will not see it in the response. And also the approach which checks the response can be used to disable JavaScript selectively on pages which have nothing to do with cross-site scripting. It can be used to, for instance, disable some security feature based on JavaScript. So there are pros and cons. This approach is safe, but also has more false positives. The version of this filter which runs on the desktop NoScript filters, which means modifies the request in a way that no code can be executed in the response. This is a double-edged sword, because most time, especially with false positives, the website keeps working normally. So user doesn't notice that the request has been filtered. But on the other side, the fact the request gets modified can cause, in some circumstances, side effects, because the web application doesn't expect that kind of request which has been modified. So the Android and future versions of NoScript block suspect requests and give user a way to override the blocking in case we see it's a false positive. So it's more draconian and also safer for the reason I already told you. Okay, the AntiXSS filter doesn't just check for JavaScript fragments or XML fragments or HTML fragments inside the request, but also performs a lot of decoding in order to reproduce behavior of many websites which don't use standard encodings. An example is eBay, which doesn't use on some requests percent encoding, but use its own scheme inside URLs. Or some frameworks which concatenate parameters which have the same name. And this can be used to disrupt almost any filter, either client-side or server-side, because you can have fragments of code in different orders. Have a part 1 of a script, part 2 of a script inverted in the request, because you just use 2 parameters and mix the code and let the framework concatenate it. So NoScript has a quite complex part of code which handles this thing. And for instance, also the homographic attack, which still affects active server pages by Microsoft. I don't know why, probably because they wanted to make the developers' life easier, but active server pages, when they output some parameter coming from a URL, re-encode characters which resemble graphically ASCII characters and make them ASCII characters. So you can attack a website with cross-site scripting, writing a script tag with the angled brackets taken from another alphabet in the upper Unicode range, and let ASP rewrite it as ASCII, and therefore the filter doesn't see it as a script tag, but the page will get to see it as a script tag because the script on the server has turned it into pure ASCII. So what NoScript does is taking into account all these transformations, so it can be fooled by this kind of attacks. Okay, it's the funnest part of NoScript to be attacked, but please, if you attack it, before sending me an email, check that you are attacking it cross-site, because NoScript doesn't check same site requests from site A to site A, only site A to site B, because otherwise it's not a cross-site scripting attack. Okay, so in the early times I had lots of reports. Oh, I've broken your filter. They used just one domain. Used 2 domains to test the filter, and when it doesn't trigger for a real attack, send me an email. Okay, these are the ones who broke the filter much more and made it stronger. Masato is a really frantic guy. He arrived to send me something like 50 reports in 3 hours. Because he is persistent, but really a good guy. He had the great advantage of using exotic encodings. He knows all the Japanese encodings. Fortunately, the W3 consortium is oriented to kill them all. In the future add-on of the web, we'll have only UTF-8 and nothing else. But yeah, UTF-7 is a nightmare. You know UTF-7, you write gibberish, and these have wonderful script, but you can see NoScript kills UTF-7 in the cradle, because no real page uses UTF-7. So if I see UTF-7, I kill it. Okay. If you are testing the XSS filter on Firefox, it Ctrl-Shift-J, because whenever there's the filter triggers, it makes a lot of output, which explains what it believes to have found. And you can use it, if you are attacking it, you can use it to as a hint to go in the right direction. You can easily understand what NoScript sees as menace, a threat, and what not. Okay, I am helping you to break NoScript. Look how good I am. Okay, what remains of this filter? In 2008, the first browser which implemented the XSS filter built-in was Microsoft Internet Explorer 8. You probably heard that this filter is quite good at what it does, but had vulnerabilities of itself because it rewrites the output, not the request, but the output, and under some circumstances can be used to inject malicious code into the target page. Chrome's XSS auditor I should say it has made as a feel-good feature to say, okay, we got a XSS filter, but as Mario will tell you, I'm recorded. I can tell anything else. So Firefox has this bug. You'll notice we currently have bug numbers in the 800,000 range. This is in the 500,000 range. So yes, is to do, but slow to do, like NoScript from Chrome. So don't hold your breath, but they are working towards XSS filter. In other words, if you are afraid to be attacked with XSS, use Firefox with NoScript. And, I'm shameless about it. I do it. Okay. I don't know. Okay, let's go. Less known facts about NoScript is that it implements some enhancements about secure connections. It's able to prevent cookies to be shared from a non-secure connection and a secure connection in those sites, which fortunately are always less, that share cookies among protected and unprotected part of the website. The biggest websites have chosen to implement a secure-only setup. PayPal is never seen without encryption, for instance. But for those sites which offers both encrypted and non-encrypted parts of the same domain, cookies may be shared. NoScript records which cookies has been seen or set in the secure part of the website over a HTTPS connection, and if you enable this automatic cookie management, it prevents those cookies from being sent over non-secure connections. So it kills the so-called cookie monster attack, which reads cookies which are meant to be sent only on a HTTPS connection by forcing a non-secure connection. Okay, HTTPS enforcing. NoScript users can implement a list of websites which are forced to use only HTTPS. Like I was saying, most secure websites are doing on ourselves. Okay, NoScript users can force those sites which don't comply with this basic security measure to comply. This one is an answer to a criticism from the Tor guys. You know, Tor is the project based on the Onion network, which anonymizes your browsing activity. They said using NoScript with Tor was a bad thing because if you whitelisted websites which didn't use HTTPS, you allowed an attacker from a Tor node to inject scripts in your whitelisted sites automatically from the node, because Tor works on a voluntary base. If I install Tor, I serve also as a node of this network, and if I'm malicious, I can inject traffic in this network. So Tor is safe for use only on secure connections. NoScript implements a policy which, if sees the connection is proxied, automatically applies the whitelist only to sites which are served through HTTPS. So all the unsecure websites are automatically blocked from running JavaScript. This made NoScript again usable according to the Tor project with Tor. Okay, what's left of these features? You may know, or you may not know, the HTTPS Everywhere extension, which is offered by the Electronic Freedom Frontier Foundation as a mean to make your online activity more secure by forcing HTTPS everywhere is possible, borrows most of the code used by NoScript to enforce HTTPS. So we are a sort of shared repository, and so this is undoubtedly a legacy. Okay, yeah. This is the web application firewall in a browser, application boundary enforcer. What does it do? What does it do? It has a language much similar to the scripting languages used by normal firewalls to define the boundaries of web applications and say this site can accept posts requests from these other sites, can accept GET requests from these other sites, from itself only, can accept inclusions or not, allows you to define a lot of policies, included anonymization. You may say this website accept connections without cookies. Accept cookies. Accept cookies only from itself. Okay. This way you can block cross-site request forgery. This feature is resistant to DNS rebinding. I don't know if you ever heard about it. And implements by default a rule to prevent websites from the internet to send requests to local websites, which is a very common technique to attack routers. To attack home routers. Whenever you hear, a vulnerability in a router has been exploited through cross-site request forgery, is always a request sent by a website to a local resource, the router. Okay, by default, ABE, NoScript, blocks all this activity, so your router is protected by NoScript. You can go there for, okay. Before ABA, we had request rodeo, request policy similar, and Chrome has isolated apps, which can be implemented in Firefox as application boundary enforcer rules. Okay, this is ClearClick. 1 minute on ClearClick. Takes 2 screenshots, one of the document embedded, one of the document embedding. When you got a document which is embedded in another document through a frame, the top document may conceal, may hide, may mask the other document to let you click or otherwise interact with the concealed document in a way you don't want. This is called clickjacking, and I suppose everyone here knows what it's about. Okay, NoScript, what does with clear click? Takes two screenshots, compares them, and if they don't match, triggers. And says, you are not clicking what you think you are clicking. This feature is being standardized under the name of user interface security. It's been standardized as a CSP extension, but it will be an opt-in feature. Web pages will ask this feature the browser to protect them from being embedded by malicious websites which want to attack them with clickjacking. Okay, I already said what I'm going to do. NoScript, what it promises to users, that they will be safer with than without it, and that when a new attack is found by researchers, it will try to protect them, and that their choice will be valued over commercial entities' choices. To you, if you report a security issue, you will be answered in 24 hours maximum. Possibly the issue will be fixed within the 24 hours. So far, the average time to release a version fixed is 1 day, but I took as a safety measure in my promises set 7 days maximum. You'll get no money, but glory. And please defer disclosure for 2 weeks, because users deserve to be protected. And this is the average time for all the users to get automatic updates. Okay, I suppose you can subscribe this list. If you get respected, you respect, I suppose. Yeah. And if you are going to break NoScript, NoScript will be your creature too, because it will be grown, will become stronger thanks to you. Okay, what you got to do to contribute? Use the forum for cosmetic bugs. Use private email for security issues. Please use encrypted email. Okay? Never use Facebook or Twitter for this kind of stuff, but I suppose I don't need to tell you. Okay, we've done it. Thank you. The